Good morning, folks. Okay, here's the plan for today. Kernels need to get optimized. You see this mess? We're leaking perf everywhere. Pretty much everything just has to get fused. So that is the initial plan. Let's get our sessions restarted here. Hey, Yannick, welcome. Happy New Year. Okay. Wait, what was the thing? I'm gonna use. It was kind of funny. I was getting tempted to work on this yesterday, but I was too tired and I knew I was going to let Claude do too much crap. So I didn't instead. Okay, so the container needs to get rebooted. If I've modeled 3D dynamics, what Python module just visualize dynamics? I don't know off the top of my head. I mean, it depends on format of stuff and what's compatible. If you just want low-level graphics, like it's very easy to do whatever, Raylib. If you want something that's specific to your application, look up a package specific to your application. Okay. Let's take a look at where we were. So this chunk thing here is bad, is what I was getting. It's actually kind of tricky to think about. So essentially, it's actually quite easy for me to fuse yeah, it should be pretty easy for me to fuse the seq length 1 version, right? Like I can just not have this chunk and I can fuse the entire thing. Okay. What about this one? So this one Log coefficient value. So this thing can get fused, right? Gate hidden. It's annoying, this associative scan. Mm-hmm. How is the credit balance too low? The fuck? Ah, interesting. Hey, Liberty. Why don't you create a Discord? Dude, we have the biggest Discord, like for RL stuff. It's discord.gg/puffer. What are you doing today? We're gonna optimize the crap out of the kernels. I'm trying to think if we want to fuse. So there's a bunch of stuff here that's slow, like this chunk operation, the backwards eating 6%. I'm trying to think how to fuse though. It's kind of non-trivial. Actually, how does this get used? So this is solve plus, solve plus. Can I treat this as an element-wise precursor? Okay, we have to be a little bit careful here. And not really, actually. This is kind of fine. Oh, you can't. Hang on, you can't. That one's actually very easy to do. We'll start with this. And then what are we expecting? So this is going to pass. You're going to pass one thing. And there's going to be a little bit of pointer magic with the addresses on state, gate, and this was it the state and the gate and the hidden. And then the output is going to be a single buffer. So wait, do you iterate over, be over the output dimension then, right? Copy pasting the code. You will see the exact way that I use stuff. I pretty much don't ever want this thing to produce code that is different from how I would write it, if that makes sense. So if I'm writing like substantially different, if I'm producing substantially different code because I'm using this, it's very bad. Indie Lab that has published papers at NERPS. Are you excited by the stuff they're doing in Ish? Okay, here's the inference kernel. Fused kernel. Combined is B13H. Combined. Hidden gate proj. I see, so we don't want to call this hidden. Hidden gate. Yeah, hidden in gate. Well, if you're excited by the stuff they're doing, then cool. If you're gonna be there and you don't think you're gonna learn anything and you're just gonna be giga depressed, then no. What's this? Combined? Yeah, so we get that we just reconstruct the inputs, right? This is exactly what I would do. Okay, getting paid. They promised to do a lot of hand holding. Graduated this. Graduated what? Graduated undergrad or graduated like. Because apprenticeships are very good, but the people that you're like the guy you're apprenticed to actually has to know what he's doing. Any good kernel debugging tools? So what I did, Tim, is I just spent the last day or two building this. So now we have profiles for all our kernels. It's a pretty big script, and this runs through NSYS, and this basically checks every single thing that we need. Undergrad? I'd only take it if you're impressed by the guy and you think you can learn stuff from him. If you find their work impressive and interesting and think you can learn, then like go for it. Um, if not, then like find something else to do. What's on the agenda? Currently on the agenda is optimizing the crap out of kernels. We have to fuse a lot of stuff. Interface being shit is really annoying. Output gate. This is actually better because then we get to use R sigmoid on the out. That's pretty good. Mirror Mirage thinking machines. 5K is man, but I mean it's like if you think you're gonna enjoy it, then do it, dude. Just don't make yourself miserable. Like I took one shitty startup internship that I absolutely should not have taken, and that was not very valuable. So you definitely don't want to just take something to take something. You can do a lot with 3 months, right? Like, will you learn more from these guys than you would learn on your own, right? If you just like set yourself up, I'm gonna go learn whatever it is for the summer. Would you learn more on your own, or would you learn more with these dudes, right? Is Opus helping? Does it take much steering? The thing is, like, it doesn't take much steering because I'm not letting it do huge chunks of stuff. Okay, so this is fine. B times H, which is the hidden. Yeah, so it should be over the output dim, right? Yes. So I like this. So Major, this is like the ideal test case because this is, I have like a bunch of different things hooked into this, and it's very boilerplatey, and it's very easy to make errors on the boilerplate. And it's like unavoidable boilerplate. Like you should not have boilerplate on the vast majority of stuff you do. In this case, it's actually unavoidable because of well, Torch mostly. So like literally all that this is doing is essentially taking this operation and putting what looks like the exact same code into the kernel instead of being at this level. So I'm basically just moving stuff from one layer to the other. But doing that manually is very, very obnoxious because of, like, in an ideal world, it would be set up in a way where it's not aggressively shit to do stuff with. And I often think it's worth spending the time improving interfaces, but in this case, there's not a realistic way for me to do it, so this is next best thing. Work at a restaurant. I will say you definitely want to get your comp to come from, your actual AI work as quickly as possible if you can. And you'll get paid much more and you'll have much more time to actually improve your skills. Yes, so this still goes there. Yes. Declaration changes. You see the amount of boilerplate? Like, there's also this output. Like, yeah, I would totally forget to just mess with this stuff. I'll figure out. Sure. Just memory leaks are like, that's not actually a bug class that matters. Like, it's very easy to not have memory leaks. Academia, from your experience, student debt, am I being too ambitious? So Benjamin, I only ever recommend people do a PhD if they want to do a PhD and they know that they want to already. You do not pay to do a PhD. You get paid during your PhD. You don't get paid very much, but it covers basic expenses. Okay, I don't think this is a true 9 mil because I think we have stuff commented. Yeah, see, we have all this stuff commented. So let's just rebuild this so we get a realistic estimate out of this. But 9.3, if we could get rid of the, this is not even the backward pass, by the way. This stuff should be pretty cheap, but it just isn't. Okay, that is still a little bump though. 7.7 up to 8. Yeah, that's a little bump. That's very nice. Okay, and oh, did we hang on. But are we not converging now? Yeah, we're not converging anymore. Crap. Okay. And do we have this thing on? Okay, we know that this thing's broken, right? Try this again. Yeah, something's messed up. Mm-hmm. So it broke my kernel. Yeah, it totally broke my kernel. Yeah, it broke my kernel though. Hang on. I'm actually surprised that it broke my kernel. That's like that was a pretty easy change. Let me see if I can spot it. Huh? Dude, what the fuck did this shit do? Oh. Tilde relu. Oh no, this is it. it look? Maybe it's the dimensions. Does it get the stream? Hey Derek D, welcome. Yeah, we got the current stream. This is fine. And then here's the tilde relu, which is the same thing. And we've used this before. I'm not seeing the... Let's see what to do. Ah, yes. Yeah, that will do it completely. I didn't notice that screw up. This is why it has to be a verifiable, because I wouldn't make this mistake, but it would be it's very difficult for me to see this mistake. Because like this is it's completely messed up. You can't put the output gate on the hidden, obviously. Do you have tests? Yeah, I have tests. It's actually better though that I run the test myself most of the time because it takes forever and just chews up tokens. It does need to be a vector out, right? Yeah, that's fine. So we're fusing everything today, Jess. That's the objective, is we're gonna fuse all the kernel ops. Because essentially it's just death by 1,000 cuts. Like every single little thing in here is just slow, and the only way we're gonna get around it is by having one big kernel. It's not just the kernel launch times either, we already have it graphed. It's kind of just brutal. I imagine we'll probably get something off of not having to call contiguous too. I mean, Torch just does so much crap behind the hood. That fixed it. Let's make sure we full converge. Yeah, we do. That's same as before. Perfect. So, what was the speed of that? It was 7.8. Yeah, that's good. 7.8 mil, guys. 7.8 mil. 2.2 mil to go. Okay. Uh, so the next thing here, this is the tough one. This is where it's tempting to let Claude do too much bullshit. I'm going to let it help so I don't screw up the porting of these ops into the kernel as well as the derivatives of the individual ops. But I want to make sure I have this set up correctly. So I think what we can do, is that we can fuse these in to, I think we can just fuse these into the scan kernel, basically. It's a little sketchy, honestly. It's a little sketchy. Opus no kernel. Again, I'm not ever asking it to like make the kernel faster. I'm asking it to do a very precise manipulation. Just because I'm using the tool doesn't mean I'm vibing crap all of a sudden, right? Let me make sure that the thing I'm thinking of makes sense first. Okay, let me just make sure. Okay, right here we have this op. Is this a simple pure element-wise op? It is, right? The simple pure element-wise op. Go away, bot. I'm gonna make a quick commit before I do this because it's gonna be risky. So there are kind of a couple places of uncertainty here. You lose an axis of parallelism. There's also numerical stuff that can go wrong. Oops. But I'll show you what I'm thinking of in a moment. I think it should work. I'm not positive. There we go. Okay, so what I'm thinking is this all pure element-wise? I'm pretty sure it is. Gate hidden. If I do it this way, is there any downside? So I'm basically thinking like we just tack this kernel on to the front of the fuse scan op. So like right here, you'd call it. This would save mem bandwidth. This would save a lot. This might be too big for Opus to do. Actually, I think if I do it in stages, I can describe this as a very simple set of modifications where it's not going to take too much control. If I fuse these two together first, right? C++ docs for Torch are hard to navigate. Yeah, because they're basically non-existent. Did you figure it out from the source code? Partially some of that, yes. And then this is actually one of the other main reasons why I'm using the model is because they've read the Torch source code. So the models are actually better than the Torch docs most of the time. There have been several things though where I've just spent like 4 hours on an undocumented bug and then fix it and then spend 4 hours on the undocumented bug. I pretty much had 2 days straight where it was just like fix undocumented bug after undocumented bug. But hey, this is what it's going to take in order to get Puffer to be fast. Like we're going to hit 10 mil steps per second. I think we can do it today. So I think what I'm going to do is I'm basically going to have it use my exact existing code and just port it from a kernel into ops.cuh. So we have just like these set of element-wise ops. And I think that this can be done as like a very small change, essentially. This can be like a very small thing. Drinking coffee? Nope. This is my own recipe. This is 66 grams of protein in a mug of hot chocolate with no added sugar. The recipe is 2 cups of whole milk, 2 scoops of unflavored protein powder, 2 heaping teaspoons of cocoa powder, and a bit of cinnamon. It's about 550 calories, 66 grams of protein. Oops, what happened? You missed stream yesterday? I didn't miss stream, my guy. I don't stream every day. Not in this block of work. In the current block of work I'm on, I've got more streams that are just all day long, right? But the trade-off is that I have some days where I do a bit of client work in the mornings and evenings, and I take myself to the gym for a good 2 hours. We're gonna see. This will be a something of a test for Opus. I think it should be able to do this because. So let me explain what this is, because it's like if you don't know look what you're looking at, this can look like something very different. So what I've done is I've described a very small, precise modification that is very fiddly to do manually because there are a bunch of places that you have to change stuff with the way that CUDA code is laid out and bound to torch, and it's very easy to screw up. So I've essentially described a very precise change. I know pretty much exactly what the code should look like, but my expectation is it's going to be faster and more accurate to apply this use Claude to apply this template rather than do it manually. So I'm not like going to be surprised by the output of this, right? This is like I'm describing precisely the op to do. Um, and this is about the level that I'm liking using it at. Lance, the topic for today is optimizing the crap out of our kernels. We're going to hit 10 mil. Okay, so this is exactly what we wanted, right? So this is the exact transformation that I described, right? Remember, I said we're going to take this kernel and we're going to put, where is it? This kernel, and we're going to move it into an element-wise hop. So instead of having a templated function here like this with all this indexing, we now have an element-wise op added to the .cuh CUDA header, and then the same thing for backwards. Little screwy with the pointers how it did this, but I think I'm fine with that. You kind of have to do this because, yeah, you have to do this because you can't get multiple returns. I actually didn't think of this when I was originally writing my, these kernel headers, but actually this makes it a lot easier to do a various number of element-wise ops if you're allowed to have just single element pointers. I like this. Carmack is reading one paper a day. That is a good thing to do when you're getting into a field for sure. That's pretty much what I did when I started in AI. You know, as I've spent more time in the field, I no longer think that that's a good use of my time. Like 1 to 2 hours worth of focused, like actual focused time per day to read a paper is a very heavy cost. Okay, so it is already trying to do the modification. Yeah, log coefs, this is going to get computed now in here. Subsequent time steps. You compute from the yes. Okay, you get your gated inputs. This is all fine. I mean, Carmack is great, obviously, right? I genuinely think if he just like came over and tried to do the RL stuff the way that I'm doing it, he'd crush it. The approach he's taking with Sutton, I'm not a huge fan of. I think obviously whatever it is, he'll execute on it fantastically. But I think that the approach I have here, which is funny enough, is a lot more similar to what you'd expect out of people with like a very heavy perf engineering mindset. I think this is the way to go overall in RL. Read some on weekends, depending on how X talks. And I especially don't like reading new papers. Okay, so we have log coef and values forward. No, that's disgusting. I think I can allow this for now. This is going to be slower as written. It is simpler, so we'll this is gonna have to get cached though, right? Like there's no way you possibly allow it to do this. So if this works, this is going to be slower than before, most likely, because we have not had this cached, but we will cache this before we're done. This is just signature update. This is also going to just be signature update. And you have to update the launch signatures, the module signatures, the prototype signatures in the C++, the expos to Python, the test. Like, it's a lot of shit to update. Context is respected. Lance, I did it for this one. For most of the changes, I don't actually need to do that because I'm not using it for large enough changes. I'm pretty much never asking it, like, implement a function that does this in English, right? I'm like describing a precise transformation to apply to the existing code. This, honestly, this might even be too much. Like, I might try this for a few weeks and decide that this is too much. Or, I think what's more likely is I decide that this is kind of fine for this code base, but like if I'm writing custom sims, for instance, I want to use it way less than this. Is this the launch? What's this? Oh, this is just the module function. This is fine. No, don't allow all edits. Make this change. Okay, now we get the fuse scan. This is gone. This is fine. It respects this, and we're good. Well, this is expected to be slower here, Tim. This is an initial thing, but what I've done is I did a whole bunch of manual profiling of stuff. I built a bunch of tools, and it really does seem to me like you just gotta fuse everything. And I will build it myself. Thank you very much. I wouldn't say it's cleaner because like these are ops that you kind of, it would be nice to have them be separated. So it's like very, very tightly coupled. And it's going to make it slightly more annoying to experiment with architectures. I think we can minimize the overhead of it though. So I think it'll be fine. We shall see. So if this even trains, we expect it to be slower. It's faster. The completely unoptimized version is faster. Well, then it's going to be way faster when we're done with it. Cool. Yeah, that's a sub 15-second solve, guys. That's Soda. Yeah, that's Soda again. Okay, cool. Let's commit this. Twenty mil is actually incredibly difficult. I think I'd have to rewrite. I think I would have to rewrite Torch to get 20 mil at this batch size. We can actually get 20 mil right now though, just by increasing the batch sizes and stuff. But that's kind of cheating. 8 mil per CPU per second. We can do that for Sim, Lance. No, this is training speed on a single GPU. Yeah, this is train speed on a single GPU. Oh, one moment, folks. All right. Cool. Let's go check what we're doing next. The output gate's super easy to scan, right? Like diffuse, right? This is a super easy modification. The one that's a little bit trickier is the chunking fusion. G-flops we pull in. Honestly, it's probably still bad, man. Everything is super memory bound, and there's still like tons of little chunks of overhead everywhere. It's just that they're getting harder to cut out. Shall I make the mistake of checking X and seeing the internet being on fire again? Let's see. Anything good? Da-da-da. No. Yeah, PyTorch on CPU is super giga bloated, like it's not even remotely close. This is true. Why do we have a million replies? Oh, did this stupid post blow up? Oh, I just saw that the stupid post, yeah. Alright. Funny. Doing the same using MPs, SCS, and share mem where we can for the end batcher. Bindings to Puff are really good. The end's a little more expensive than yours. We've got plus minus 12 kilobyte ops. So our Lance, our new buffering of host device transfers will help you a lot because now we're buffering the transfers to GPU. That'll help a lot. It's substantially better than the Puffer 3 architecture for that. What the hell is this? Fine. It can do this at once if it wants to. But I have to check it more carefully. Haven't merged main. Well, 4.0 is super unstable, Lance. I didn't tell you to, like, just use it. I'm saying that the new architecture, though, once we have it fully done, will be substantially better for that. Okay. It's this extra sigmoid. Few nans, getting yourselves. Net safety. I'd assume that they're just a bunch of numerical screwy things if you're using any of our new models yet. I mean, this is still a work in progress, man. Everything needs custom kernels is the annoying bit. Like, the new model's actually quite simple if you look at MinGrew. Like, it's not that much code, right? But the thing is, this is just so unbelievably slow without kernels. Even if you CUDA graph it, like, you just throw away half of your performance. So if you want a more stable version, you can just use this and see if this is more stable without the kernels, at least for these ops, until I've had time to fully test. But you'll lose half the perf. Agile RL collab. Oh yeah, I've seen some of their stuff. I forget, are they still alive? Or are they the ones that are doing language models now? Ah, yeah, they're doing LMs now. They got themselves some clients, so I guess they're alive. Good to them. They got pushed by money mission. Yeah. This is why I don't take investments, man. This is why I don't take investment. If you just don't try to grow faster than you do organically, you don't have these problems. I mean, it depends what you want. Okay, so what this is here, scan result. Yeah, so what this is here is this is now taking, it's replacing this chunk operation. This is the goal, right? We want to replace the chunk because the chunk forward creates a cat backward, and the cat backward is like 700 SPS overhead. What would you like the comp to help you in the 4.0 open source? Catch all the dumb stuff that I've basically like catch all the dumb stuff that I've broken and help me get like minimal fixes and patches without trying to creep new content into the release once it's stable. The goal for Puffer 4 is that we just have everything super fast. We have the best baselines on all the M's. The M's are clean. Like we just basically want to have this be the super fast, super clean version of Puffer, where we can run 100,000 experiments and start aggregating results from everything. I think we'll probably do it in a way where the community can even contribute results as well on new environments. So we build up this big dashboard of experiments that really tell us how everything scales in RL. I think that the goal for this is to have RL be faster than ever by about at least 3x, to have certain settings of Puffer be 10x plus faster. Like small batch sizes and other sort of academic experiments are going to be way faster than 3x. And then we want to have a giant data set of experiments as well. So I think that like the easiest thing for the community that's not the easiest thing for the community, unless you have experience on this type of stuff, is to help on like really solid experiments and benchmarks. Like, believe it or not, the science side of RL is now going to be more accessible than this stuff. So it's actually going to be pretty easy to contribute to the science in Puffer 4 because you will just need one GPU to run 1,000 experiment sweeps. So I think that's probably the best thing, is like helping on experimental side and like starting to get into the science, which is cool because in Puffer 3, like the community could get into the end building side, but it was harder to do like more experimental work because you still need a few GPUs. And now it's going to be that the community can actually do experimental work. It'll be nice. And I don't think it's unreasonable to ask, even for architecture stuff, I don't think it's unreasonable to expect the community to be able to edit this, right? Like, this is basically the same as the torch. Obviously, I don't expect people to touch the kernels. Da-da-da. Okay, this is good. The sigmoid grad here is a little iffy, but I'm pretty sure this is, yeah, this is derivative of sigmoid. I'm gonna clean this up into a really nice ops library. These are the launch functions, this is fine. I think once we see the perf on this, I'll decide how much of my time I want to spend cleaning up this kernel today versus looking for other remaining perf optimizations. We'll see how close we get to 10 mil off of this. We could hit it, especially once we do the caching. We might hit it. And again, this looks like a bunch of changes, but this is literally just the module binding. So this is just Torch being a ton of code for no reason. That's what we expect. This will actually shorten our test, which is cool. This goes into non-kernel path now. And I'm pretty sure with this, yeah, this is basically what it'll be. So you can see here, this whole path, so this is false, you get here. The entire path, it's just one linear layer and then one kernel for the gate. Which means that we no longer have we should no longer have cat backwards in the profile, which was 6% before, as well as some additional memory bandwidth overhead. Eight 8.6, fellas. Still about 15 seconds solve. Let's commit that. Today might be the 10 mil day, Spencer. We're at 8.6 with some awful, awful stuff in the kernel. All I have to do is I have to be vigilant and not... I have to just be vigilant and not give too much control to Claude and make a mess. Because this is basically something where it would take forever to do this manually, but I have to make sure that we still end up with like solid kernel code. Oh yeah, it's 20 mil on eval, by the way. So the forward passes are 20 mil steps per second. Here, you can go watch that again. Let me use the restroom real quick. Whoops. Okay. Ugh. Breakout in 16 seconds. Breakout in 16 seconds. Yeah, it needs to be 10. I actually think we're gonna get, the thing is we have not re-optimized hyperparameters, and PufferLib now has a totally different profile of fast configurations than it used to have. So I expect that just rerunning hyperparam will get us 10 seconds, but we'll see. We have to get like apples to apples speed up before we do that. Okay. Right, we want to run improv. So we want to see how fast this kernel is. My hope is we see like 20% overhead in this kernel or something ridiculous, and then we just go, yeah, we make this kernel faster, we win. But I think we're still going to see something of a long tail. I think we're still going to see something of a long tail. Okay. It's going to take a while to generate the profile trace. So the other thing, folks, we have like 2 million step per second overhead in the optimizer. And I don't mean the backward pass, I mean the optimizer. Like after you've done lost dot backward, optim dot step takes 2 mil SPS off. That's kind of an issue. I don't know what to do about that one though. That one's kind of a pain. And still though. It's kind of crazy to think that this is still real. Like you can see right here, this 4-layer network. I didn't mess with the settings. It still works. Get rid of what? You can't get rid of muon. Muon's really important. We ran pretty comprehensive experiments. It's a big upgrade to Atom, and it's not even... It's a chunk of the overhead is because of muon, but like a chunk of the overhead is just because of the way that you have to apply the tensor updates with Torch. All right, here we go. We got our kernels. We got all our stuff. Hey, this is exactly what we wanted. Look at that. So now we have the slow thing is actually just this kernel. Look at that. So we just have our kernel here eating 20%. This is what I just said would be the best case scenario. It's actually kind of awesome how well that just worked. Because this is matmols. I actually don't know what these are, so we'll have to figure out what, like, where these extra element Ys are coming from. All these. Because that's another 25%, but then right here we can kill this. SGD outperform one on smaller nets. No, it doesn't. Unless there's some SDG that you mean, but SGD, no, it does not outperform. It's shit. Muon was pretty instrumental in Puffer 3. So unless you have like some really compelling experiments, I mean, you can go ahead and run the experiments on Puffer 4, right? Once we have it, that would be very easy to swap. But I highly, highly doubt that you just vanilla SGD is better. I think that's, yeah, that's troll. Okay, so 20% overhead. And 15%, okay, 21% overhead. I think we're gonna apply one quick optimization maybe. And then we're gonna do some heavier stuff. Yeah, because this is a mess now, right? Was the thesis on why smaller video match? Because there's only so much noise in the gradient, Spencer. So once you increase above a certain batch size, like you already have a perfect estimate. Vanilla. LLMs and 30 prims. Okay, so completely different setting from what we're doing. Cool. I will pay attention when the GPT-2 speedrun starts using SGD instead of Muon. Yeah, I need one buffer. So this is just the easy optimization. I think the rest of the optimizations are substantially harder. This one's easy. Like this here, this should be like 5% overhead for no reason right there. And yeah, that's fine. So this is, again, all this is doing now, we're caching this output. Yeah, you see it's just gone from here. Wherever it was cached. And we have all this branching and all this crap that we gotta figure out. I think this should get us above 9 mil though. We will see. Some of these flags are a little suspicious. Eight. Interesting. About the same. Non-gradient based? No. Doubt it. At the very least, you have to go pretty far off what is done, if you want to play with that stuff. Okay, so interesting. I'm actually very surprised that's not like immediately. Smallest learning rate, tiny. That's very weird, Spencer. Really? For Muon, that's really weird. Like, if you're making the networks way bigger, then maybe. That seems very odd to me, though. I think we are going to have to just spend some time optimizing kernel. Well, we can actually, we'll have it fix up the test first. Yeah, we'll fix the test so we can actually get the timings first, and then we'll do it. That way I don't have to do a perf test during training. It'll be much better. Oh, we did take 5% off. Cool. Yeah, we did take 5% off. Very nice. So where the heck these come from? Where the heck these? Yeah, there are lots of these little kernels. Yeah, this will massively change the test in here. Oh, that's a lot of changes, my guy. Now we have to read them. Okay, we update all these. We update our mallocs. Okay, hidden prod, fine. Okay. 3 times, yes. Okay, I can tell it's only like 11:30 and I'm already starting to get lazy on this, so I gotta be more disciplined. This one is fine. What was our kernel test? Oh yeah, Python setup.py build. That's gonna get fused. Today could be the 10 mil day. It could be the 10 mil day. For anyone who's new around here, I stream all my dev. I'm typically making RL go fast and be sane. Sometimes I'll go dev as well. If you want to support my work for free, feed the Puffer star on GitHub. We're almost to 5K. It'll be so awesome to hit that. I work on this at least full time, so it helps get the word out. We have all these M's that you can test right on the website too. Some are games, some are not. Games are nice for testing, but RL can do way more than just play games. Alright, what are we doing here, Opus? Fuse test, quick update. Yes, yes, good, correct. Mallocs. Okay, we'll double check these init when we go to do numericals, but we're not doing numerics yet, so that's fine. Open source URL that has the same scale? No, because nobody has that number of GPUs open source. We can get very close to the same data scale though. Like with Puffer, we have, even with Puffer 3, we have on our like neural MMO 3 environment, we trained that for 12,000 years worth of sim. So we're in the ballpark of the amount of data that they use, even though we have way smaller training hardware scale. And I think we should be able to exceed it in the next version. Like we should actually be able to train agents on more observations than OpenAI 5 did, though with much smaller models. You know, maybe a few million params. You'll still get some awesome behaviors out of it, though. Do this, and then this just needs to get ported around. This is fine. So okay, check that. I'm gonna grab a drink, and we will be right back. That's funny. All right, I'll be right back. All right. There we go. Reference implementation. This has the chunking. Yep, that's fine. With the gate. This does not allow you to have an expansion factor anymore. Reference implementation for fuse scan. Yeah, again, it just puts this into here. It chunks. That's fine. I'm gonna feel way better though once I actually go through and have this like, and get it cleaned up nicely. And this will be a big delete diff. I think it just deleted something it shouldn't have, let's say. Interesting. It's not even there. Fine. And then we should be able to run our test, right? Which is this one. We don't need this. Good. Look at that. Oh, that's a slow backward pass. 670. Yep, that's solid. Cool. We don't even have the fuse loss in there yet, and we're still fast. So that'll be plus a little bit once we get it. 82 and 107, right? Let's make sure real quick. Let's make sure we still train. We should be fine. But now we have a fast benchmark standalone for that kernel. I don't know why I just went and got myself a cold drink instead of getting myself a coffee, but we'll get a little bit of Optimum done and then I'll actually go get myself some caffeine. Cool. .9 mil. Looks stable. Yeah, 12. Holy, 13 second solve. 15 full solve. Perfect. All right, so now I have to look at this manually. Multiple times a day is standard. On a good day. I mean, it's more just like a lot of the work that I do that seems very boring is setting up to be able to do this. Right? So when it looks like stuff happens very quick, it's because there's been a lot of work put in ahead of time to make this possible. I actually want to do. Small team making. Wait, no background in RL, leading a small team making a designing a collective intelligence system, currently enabling it to create PufferLib M's. Any best practices, what makes a good N? Keep it simple, keep it fast, avoid all the pitfalls that I have listed in the tutorials on the docs. Reference some of our higher quality code bases for it. Price of complexity in RL is way higher than the price of complexity elsewhere. There is some stuff on like designing good ops and action spaces that you can find in some of my articles on X. Pretty much through most of my material I've covered like environment design practices. I gotcha. Yep. Hang on. Okay, so these two kernels here, I think we can pull another 500K to 1 mil off of these. Like, look what a mess these have gotten to be. First time step, use log state. There's something I want to check real quick. Yeah, this is the C++ one, right? How would you learn C if I could start over? Well, I'll tell you, Carter, the main thing that just screwed me over. So when I was taught C in undergrad, one, the professor was terrible, but two, the biggest thing, if I had like the single biggest thing, all right, they didn't tell me that an address sanitizer exists. Like C with GDB and an address sanitizer is good. C with like, I don't know, it segfaults, I don't know what to do to fix it is terrible. So just like basic compiler tools for debugging. Okay, so this gets chunked. I want to see what this, I want to actually understand what this pad is doing. Because this is kind of wonky, no? Because you pad onto this, right? You get state log, and then log values. Okay, and then this one gets log coifs, then padded at the end. Main thing I see is all the branchiness, right? I'll explain what I'm doing in a second. Oops. Okay, so what I want to do is I want to start isolating, exactly why this kernel is slow, right? Where's the perf coding coming from? I think that you can do it just like comment this one, keep this one. ED micros forward, right? I actually bet that this is not going to work. I bet that, funny enough, this is the first spot that is not going to work. Because this is the first spot. This is actually the spot where I would want to use my judgment a little bit more. It's actually not bad. Okay, so this is no branching. So this shouldn't have removed any of the actual ops really, but this did remove a bunch of branching. So we want to see if this messes, well, if this fixes the perf. If it does, then we just have to do branch optimization. Otherwise, we have to do ops optimization. Main use case for RL, so RL for crypto trading. AG, decent. What? Industry plants. I mean, we don't just have one main use case, right? We do RL generally. So Puffer builds the fastest RL tools out there. We have a big suite of test environments. We build a ton of infra. We do algorithm research. And then professionally, we build custom sims in a variety of different domains and apply our tools to them. Now, we're able to train at millions of steps per second on a single GPU. So we're really just able to, any problem where we can build a high perf sim, we can just crush a ton of data really fast. Okay, so good. We didn't spend too much time on this, right? Because this actually didn't help. You see? It's actually, the branchiness didn't make a difference. When you're adding the finance end, I keep forgetting, Jess. The one that we're adding is so basic, though. Like, the way cooler one is the commerce end that's already open. So, machine learning researcher for DARPA. I want a highly funded startup. You can go try to start one. The problem at the moment with RL is like there's so much hype around language models that if you try to go get any big amount of money, uh, for the most part, investors try to steer you into doing language model crap, which is why we're not taking funding. Because we don't want to do that, among other reasons. Okay, let me see what else this would be then if this is not the issue. Commerce Env. No, it's there. We tweeted it, Jess. It's not in Puffer main. It's the archive env. What types of sims have you made? We have one in commerce. We've got a couple in finance. We've done stuff for animation before. We've got like a little bit of defense adjacent stuff, and we'll likely be doing a bunch of game stuff in 2026. Use Puffer for robotic arm. If you have a compatible sim or you're building a compatible sim, then yeah, of course. Okay, where is our compute going? How do launch args look for this thing? Do we just have stupid launch args? Seek size of total. Wait. B times H. Hmm. Breakout was boosting on SPS with DQN. That's funny. Purple. Yeah, carpool is not a good env. It's so simple you can solve it with anything. Pong is also too simple. It seems that, so from our work, breakout is the simplest env for which your results are usually meaningful elsewhere. Scan forward kernel. I mean, I do wonder. We can just go through the block sizes real quick, right? There's no harm. '81, 106. Weird that didn't make a difference, right? Oh, well, it's definitely worse if you make it small. Interesting. Briefly catch up viewers on what you're working on. Objectives, can't really see the text. Well, it's a problem if you can't see the text. It should be streaming this at 1080p, so if you're not on your phone, it should be visible. Let me go look. Oops. You can totally see the text on this if you're not on a phone. Yeah, so what we're doing though at the moment anyways, we are working on optimizing the custom kernels that are needed for this network architecture. It's an architecture that should be very fast, but it's not fast naively. Like, it needs a bunch of custom kernels. And it turns out that you really just have to fuse all the operations together into big single kernels to make it usable. And that's what I'm doing at the moment. We're up to 8.8 million steps per second training. We're trying to hit 10 mil today. Oh, okay. Hmm. Yeah, there's really not great options here. I bet you we just have a flat profile. I think pretty much from here, we have to look at either precision or operations. There might be a few things we can change. We'll see. Precision of this op's important, though. Let me see. Jess, I'll find you the env. It's not on Puffer, like, it's a client env, but they open sourced it. Oops. Oh, actually. There. Here it is. You can look at them up here. Sequential nature. Okay, I guess we can try that. Like, fair enough, my guy. I didn't think of it this way. Let's try it like this. We comment this function, yeah? What's this? Because it could be way more overhead here than it was before. This is FP32. Ah. Yeah, that's it. Okay. Okay, so that's sketchy. So then outside of this, the whole rest of this function is 30 micros for the scan, which is not bad. And the chunk. That's not bad. What are you working on today, Kyoko? We are fusing all the kernels together. Well, all the min group kernels, basically. There's a lot of overhead, and it turns out we can just fuse stuff. We're already at 8.8 million. I think we have a way to get to 10 million just off the kernels. We shall see. don't think I'm missing something on this though. I'm pretty damn sure. No inputs are negative. Yeah, which we have this already. Hmm. This is very interesting. This is where my math bites me a little bit. Not even math. This is just like I find this type of stuff very unintuitive. Does this work though? To get definitely not mathy. Okay. Actually quite complicated. Another rabbit hole might be. I'm wondering if this is like a standard thing though, where they have chunk of code for this. Because like for the sequences are not going to be massive. Yeah, so you can do it. It's much more complicated. Yeah, it's annoying because there is something here. I actually don't even know though if this is going to be better on the small sequences. Hmm. Let me grab a drink and tell the dog to go shut up. 1 second. Oh, let me look at this first. Uh, can't do this on thread 0. Oh, maybe you can. Maybe you can. That'd be funny if that works. You see? And you made a mess in the process. Sigmoid T proj. Oh no, just move this. Okay, we'll try this real quick. I don't know if this is good. Because the thing is, so all this is doing is it's launching additional threads to do the first chunk up here. It's launching additional threads to do this. But I actually don't know. Let me get my thoughts straight and I'll explain. It's a little weird. We'll also just be able to try it in a moment. Okay. A paralyzed sequential scan. Sort of, not really. We don't necessarily need to. I don't actually know if the full algorithm would be faster with the seq length. Difficult env I've worked on other than NMMO. Honestly, like neural MMO is just so much harder than the rest of them. Like it's not even close. So like I could pick like a medium complexity env. But like as for big ones, neural MMO is just, it kind of blows everything else out of the water. It's unsolved, and we've run 650 bill obs. Okay. What? What? What the heck? I don't even know what I just read. What the hell is this? No. Oh, that's so funny. I don't know why the hell you do it that way. We'll see that because we're just gonna test this and revert it anyways. That's not gonna give you something useful. Does QB have a hierarchical scan? I didn't know that existed. Is this good though? I mean, it links us to this. Okay, this is all getting reverted, I'm sure, in a second. Didn't it only changed this one, right? Yeah, okay. So we will see. Right, so we wanted, it was 80 and 107. That's probably the easiest. That's so slow. Yeah, that's so slow. That's shit. Okay, let's get rid of that crap. Get rid of this crap. Yeah, this is why you don't just like vibe shit, because it's like, it's dumb, right? Okay, so I think what we can do. This is just okay. I think what we want. Yeah, I think what we want to do is we basically just want to do what we did before, where we launch the full set of threads, and then we just subset for the scan. Can't sync across blocks in one kernel. Can't sync across blocks. Hang on. Let me see if this makes sense. I don't think so. Yeah, we're not doing two kernels. Like, it drives me nuts that you can't just find the. So fucking obnoxious, man. Blocks, threads, yeah. How many blocks? How many threads? Blocks, threads, 0. Let's try to guess. Blocks. Thread size. Yeah, so it gets blocked to this. cross blocks. Yeah, so in order for this thing to scale nicely, well, hang on a second. The way I have this damn thing now, right? Look, the way that I have this damn thing, add a chess set of positions to train text file. I mean, you can do that for sure, Jess. I just don't know, like, there's not a nice way to integrate it into the main library, obviously. Distribute those positions across the games. Oh, okay, I see. So not training like supervised, but training from state. Like starting positions. Yeah, you would just do it kind of like the way that we have our mazes done, but from file. Click a shared init angle. Yeah, this is actually a tiny number of threads, is what this is, right? I mean, all we want to do, I think this will work. Doesn't scale great. It'll scale way better than Puffer 3 still. And this inside is correct. Yep, this is what I have. And this is really the last thing that needs to be fixed, so. Oops. Okay, so. Yeah, you do this one, and then you sequential scan. Yes. You know, this is what I did before, though. Yeah, I'll mark it. Yeah, so this is where we're starting to like flounder with it a little bit. And it's because I'm off of my, it's like, and it's not because I'm off the manifold of the LM or some bullshit. It's because I'm off of my own. This is kind of a weird synced op to think about. I'll let it play with this, but I think this is the slow one. Mm. This is slow, right? Yeah, this is like When I decide to write it, Hyper, fixing some things first. We're gonna get our perf. Yeah, I'm pretty sure I'm correct on this. So the idea here, right, is that we just want to do the first chunk of it full in parallel, and then do a thread sync, so everything is still loaded into memory, and we use a subset of the threads to compute the final loop. And it's just kind of being pretty stupid. Oh, okay, I see. Yeah, I see. Hang on. Can't sync across blocks. Yeah, huh. Let me think what we do. It's very awkward to do this in 2 launches. You know, hang on. Try this. Hey Peru, welcome. I don't know if you've seen the latest VEC. We've got it pretty dang clean. It took a lot, but it's nice and stable, at least for what I've been using it so far. For viewers here, Peru wrote the first version of the new VEC, and was very, very helpful in getting it up and running. I'm gonna let it try some stuff here because I'm gonna be able to test the speed afterward. I think so. Autograd and Torch is like awful, right? Like I don't want this to go to two autograd ops. In fact, I think it was the chunk backwards was the really bad one. But I don't think that it has to care. Oh, and in fact, yeah, it's even better because we can just put both of the launches in like this. That's actually, yeah, we'll put both launches in there. And then we don't even have to edit the module, which is good. A few new improvements add GPU multi-thread batching plus fused kernels without params. Previous LSTM cell. What have you done? Wait, 4.5 mil. On a 2080 is quite good. If you're optimizing the LSTM cell though, you're gonna have a rough time. If you link me though on the Discord or whatever, like wherever I go check it. Okay, there, that's fine. Yeah, tell me where to look in here. This is just template matching. Where's the batching stuff? X is slow. Let's see. So wait, PufferLib CUDA kernels. Like what? Wait, this is an LSTM kernel. What? Oh, did you write? Wait, what? There's no way you beat their LSTM kernel, right? Like that's actually a really optimized like cuDNN kernel. Dual linear. This I'm actually interested in what you're doing because you have wait dual linear forward. But wait, then are you gonna still use? Oh, you pulled the internals. Cool. Then that'll be a cuDNN call. Sample logics kernel. Is this Gumbel? You have a lot of stuff in here. I'd like to be able to check some of this. Wait, where's this double? Where are these come from? Dual linear forward kernel. Where are the kernels? Doesn't work, so I add their internals. In one kernel that does log problems. So that one is nice. That one's actually nice. Yeah, dual linear does values plus decoder. But when you say it does it, where's the kernel for this? Or am I blind? Oh, here it is. Wait, this is a manual matmul though, dude. This is not using this is not using tensor cores. I guess for values and decoder it doesn't matter as much. Probably. If like the number of actions is small. This is not using tensor cores though, for sure. Number of ops doesn't matter. Are you testing stuff graphed though as well? So I've been kind of at this for the last several weeks, and there's a whole bunch of stuff you have to do to test perf on these things. So you can check the per operation times, but then you also have to check it graphed, because if you're not graphing it, you're going to count launch times on top of the memory bandwidth overhead. Using add mm active. Wait, obs though I'm using add mm activation out. Huh. Full profiling added plus mem profiling. What did you use? Wait, what do you mean to the .py? Did you use the torch one? The torch one's really bad. Wait, C native CPP. Hang on, what did you do here? Wait, what? Where's the thing? I'm confused. Where's the profiling stuff? PufferL.py plus memory profiling. Okay. So if it's this, hang on. Okay, so there's been some new stuff on the profiling since you've been here last time. I did a whole segment not being able to get good enough profiling results out of Torch, and also profiling at the Torch level is not great anyways. So what I did here, so we've got this kernel profile script. This does raw CUDA profile with NSYS, and it also does the Torch bind versions, and it also does the C++ Torch versions. Let's see this one. LSTM wrapper. Is this CUDA graphed or not, by the way? Is it a batch? Tried CUDA graphs. CUDA graphs makes a big difference. It was a pain in the ass to figure out. It beats the purpose. It uses extra Alex. Wait, what? How does it use extra Alex? You trace it and then you replay it, right? And then it just replays the exact graph. We're down to 9 without any Alex. How do you only have 52 kernel launches? Oh, I suppose you have the LSTM. Copy the obs to the correct graph. Every segment to copy. Yeah, so you need, that's not an Alex, it's a copy. You can do it directly if you want. Like you could do it directly from the end, but I think we have an intermediate buffer at the moment. But we got like 2-3 million SPS out of CUDA graphs. You've got a lot of stuff here, and I want to look through it. Maybe let me fill you in a little bit on what we've been doing here, so that you can have some context. So we now have like custom kernels for MinGru, which is at least substantially more seek parallel than LSTM. And from our experiments, it seems like we're getting comparable learning as well. We have training up to 8 point some odd million with parameter and flop match to the LSTM architecture. We needed to CUDA graph trace everything, and we also, you need to just fuse a ton of little operations. I'm almost done with the kernels for this custom net. I think that there are still some other ones, probably like action sampling and other stuff like that I want. So you actually probably have that there. Actually, even fusing stuff like the value function and such, that actually might help as well. Because like you just need to get down the total number of things happening. Now I will say that for just pure launch overhead, right, you kill that very nicely with CUDA graphs. I tried very hard to get around doing this, but it really does seem like you just can't. Every single little thing you do is a separate launch. Otherwise, so you really need both from what I've seen. I think we're going to be able to hit 10 mil just off of these kernel optimizations, and I think we could get even faster with a few more fusions. I'm trying to think about outstanding stuff. I mean, I'd love to have some of the stuff you've been working on the latest 4.0. Like, if you can start playing around and seeing if you can speed up this with some of your stuff, that'd be awesome. Don't understand the train loop only on the evaluate. Yeah. Yeah, you kind of, they both need to be, like, they both need to work. Right? Like, the problem, okay? So the problem with the LSTM architecture is not in evaluate, it's in training. Because the LSTM, the map moles are iterative, right, over the train loop. You can't do them parallel. So MinGru lets you have parallel mode training. It lets you do all the map moles in one step. Try out. I'm having very bad luck with RunPad. We only got 11590 that I'm using at the moment. I can get you some. I can get you 4090s though for sure. Is anybody watching that knows what boxes we have open right now? We should have several. Very bad luck with RunPod and Vast. Do I have the? Are you already on the cluster or not? Fat ends. The learning part is bother with improving learning for my stuff. Yeah, well, I mean, our core assumption and everything, right, is that we just like we make the M's fast. If the M's aren't fast, you're screwed no matter what you do. Nope. Okay, so I can get you. There's a user agreement I have to send you. Eval, any reasonable M that eval plus M is 95. That is not true. Yeah, that is not true. We build fast M's for clients and it's 0% time at the end. And then eval is like 25%. Tiny puff. 0. Oh shit. Art, I didn't know that you're on that one. I put somebody else with a couple experiments on that one because all the GPUs looked idle. You can go reclaim them later. Mostly just for today, anyways. I can move those onto Tiny Puff 1. Try Puff and my end like Puffer Drive. Wait, my end like no, Puffer Drive is not like Puffer Drive is also can be fast, right? So Puffer Drive right now it's mostly bandwidth overhead, and that'll be cut out in Puffer 4. Like we're gonna have that thing well over 1,000,000 steps per second training. Actually, the only reason they're at 300K right now is because they have a really janky encoder. Even like neural MMO, we're gonna have million plus. Why a random GPU is active? Yeah, my bad about that, Jess. Uh, forgot on that one. We'll have to move some stuff. Wait, did I put anybody on Tiny Puff 1? I'm trying to think why I would have put you on 0 when that's usually the one that I run stuff on. Is anybody on 1? I mean, ideally, the best thing would be if we could give him a single GPU box, because he doesn't need a 6 GPU box to test stuff. The 6 GPU boxes are for running heavy experiments. All good? Do I have you on Discord, Peru? I can send you the form. It's just like a sign here saying you won't do bad things on my cluster. Speeds up Blaster, Pong, and Breakout. Okay. Let me go grab this. Let me go find the user form. We'll get you a GPU. Stir. The heck is this? There it is. Download. Where's your thingy? What's your... I thought I already had you on here. Why don't I have a DM on Discord? Most important speed up though is by multi-threaded GPU batching, not just M. So the OBS is parallelized with CUDA. Wait, OBS action copy is parallelized with the CUDA kernels along with the M's. The main README has all the not just the GPU batching. So the OBS and action copy is parallelized along with the M's. Is this different from the thing that what we have where like you just want to have the stuff copied onto the GPU by the time you need it? Eval torch. Okay, I gotta read this as well now. What's your user on Discord? I'm not seeing your messages. Let me rebuild this real quick. That's fine. Oh, dummy. I just said hi on Discord. Where is it? Hang on. Hang on. This is requests. Did you at me on the channel or something? Oh, I see. Yeah. Hang on. Get you this form. Here we go. Here's your EULA. I'll get you on this. What I'll do is I'll get you access, and then you're gonna have to figure out from the Discord which of these boxes is open. So you can run some experiments. Either like Spencer or Bet or somebody should know. Okay, cool. Yeah, I really don't care that much around about credentials, to be honest. It's as long as you're doing cool stuff around here, I give people access. Don't need this. $132 micros is slow. So if you're not, yes, but not in the way people were expecting. Okay, this is crap. Let me go look at the kernel. I wanted this to be. Wait. How can that possibly be slower? Yeah. This is the. Yeah, the thing is the interface for it really sucks. It's very, very difficult to make sure you're using it in a way that you're not just handing it control of everything. Okay, where'd my timings go? 32 micros is slow. But this is with additional stuff used in, right? So 32 micros. I don't think this helps. It's probably just the mem bandwidth, right? Oh, that gets us to 78. How's the experience? With what I'm doing now, it's fine. Advent as code. Calculator signed agreement. Let me send you the. Hang on, let me put this away in my folder. Oops. Thank you. And let me get you your credentials. User. Link. There you go. Did you write a blog post? Not yet. I am going to still. Okay, 75 micros. Interesting. I think it has to be. It's like really annoying because I think it has to be fused, right? I'm trying to think how badly this thing scales. Block synchronization problem, yeah. Super memory bound. This is why CUDA graphs don't help, right? Synchronizing across blocks. So I'm trying to figure this thing out. So we need, let me just really understand this. I want to make sure I'm not just fundamentally. So basic, but I think I could be messing something else. Within each block. Number of block sites per block, right? Well, then hang on. I'm not sure I know what the hell I'm doing here. Oh, because it's still parallel over hidden, right? Okay. tried adding this message on Twitter. If there was another message, I do not see it. So this is basically going back to what I had before. We're doing code reviews. I added a PR that speeds up Puff Advantage kernel. Ooh. Puff Advantage kernel is like 1.5% of our runtime, but we'll gladly take it. Float 4. Wait, what? This is plus 465 lines somehow. Oh, because it's a test. Okay. Okay, and then the actual changes are smaller, right? Yeah. Float 4 star. Load 4 elements at once. Huh. I did not know you could do that. This is probably what we need, I mean, this is probably what we need, the thing I'm doing right now as well, isn't it? Interesting. Well, I will have this merged. Let me play with this actually. Let me finish this optimization and then maybe play with this in the kernel I'm working on now. This might even be helpful here. And make sure it's not messing us up. You shouldn't need shared. Okay, this is all the same. So this is just the stuff that we had before. I'm gonna have to figure out what the heck is doing with this, but yeah, this is too much flawed for reference. This is definitely too much flawed. I'm only doing this because we have verification. But I think I'm gonna go back to the original version after this and then try to like iterate from there using what I've learned. That's saying if it works. Not particularly, because this is like a few lines of code off of the thing that we had to begin with FBR. It's just that it looks like a big change because it made a mess in the middle. Yeah, we definitely don't want two kernels. build this. Probably forgot to update the profiler. Probably forgot. Yeah, so this is stupid slow. Yeah, this can't be thread 0 only. That's why it's stupid, right? Because now we have, hang on. How many do we have? Yeah, so now we don't have enough because see now it's let me use the restroom real quick. I can actually, the good news is though, if this screws it up, I'm just going to go back to the version we had before, and it's actually a pretty small change. I had it backwards originally. I was making the wrong number of blocks, and I think it should get us something. And definitely the bandwidth is the big issue here, so. Right back. Each thread stay active, yes. T time steps. What the heck? Eh. Okay, this is messing things up at this point, so expect that we're just going to test the design and then revert. This is an excellent example of like Claude doing too much shit and making a mess. Actually, wait, I think it undid the mess. Hang on. Buffers. Back to 80 micros. Two micros. Ah. Oh, it's stupid. I see. It just went back to literally the exact same thing from before. That's not terrible. Wait, B? Basic chill. I'm trying to think of what because now this stupid thing has me confused too. Um, hold on. It's B times H. H. Oh. Uh, yeah, this is actually gonna be fine. Oh, I think these need to be blocked way better, don't they? Okay, hang on, let me think then. Hello, welcome. Yeah, the blocks have too little work, most likely. Too little and too much work. It's funny. Well, now I'm not having as much of a good time of it because I'm being lazy. It stops being good the second you get lazy. I think we go back to the previous dip in a moment. Yes, you shouldn't need the shared membership. Yeah, I'll let it do this, but then we're gonna end up reverting it because I think this is gonna be super slow and way overcomplicated. And then what we'll do is we'll go back to the version that we had that was naively fused. We'll see if there's some load optimizations or something we can make there. Actually, I'm curious. If we look at this PR that we just got. Where's the PR? So I was given benchmarks. $10x speed up here. This is actually what we have. So possibly we can do this. Yeah, we're gonna completely revert this crap. It's so bad. And then it's basically, it'll either be the 2-kernel one with optimized loads, or it'll just be the single kernel one. But we can't have it at 80 ms. Tricky. Let's see, it's the same freaking speed. Okay. Let's do. Let me go check the current version that we have. Believe we have the fused version here. Right. Yeah, here. Yes. Estimate the speed up. No, because if I give you some number on this, it's going to be a big overestimate for other work. Like, there's going to be stuff where it's legitimately is 10x, but then there's also going to be stuff, like, really important stuff where it's basically nothing. The thing that's stupid about it is the speed up is mostly a function of how, like, bloated and crap the code base is that you're working on, right? Yeah, see, we don't want this loop. No, I don't like this. Optimizing memory. I'm optimizing several things. Memory bandwidth is one of them. And just the API, man. We probably shouldn't even have frickin' shared memory here, honestly. We probably shouldn't even have this here. They have really shitty limits from what I've heard. Well, we have this, it's a shitty layout, like, it's kind of weird because, like, none of these ops are actually intensive, but we have one thing that's purely sequential and then the other thing that's full parallel. It's like a weird in-between thing. I mean, is this really that much work to ask? E times 2. Each threads per block. End up getting T. So you end up with a constant factor difference. I think it's better though, because if you do the prefix thing later, you get log depth instead. Hmm. Hang on, that seems very odd to me. That actually seems very odd to me. I think this design was way closer. Okay, we're gonna try it like this. I definitely understand what's going on a lot better now. Sequence size. So I don't understand why this thing. Why is this not at least 128? It shouldn't be sequence size. This doesn't help. So B times H. Blocks of work. H. Wait, how does this make sense? Oh, because there's no seek anyways. Okay. Well, that's weird though, because then that's like implying it's maxed. That's what. So weird. Okay, if I just comment this thing though, right? Like, okay, 50 micros off. Hmm. Such CUDA. I could also just go look. We have hardware up we can take advantage of or no? Speed. Is there like, are there ops that just like do this? Like X on a few things or something? We're not doing fucking Cutlass. Yeah, no, these are just fast versions. Yeah, I was looking for a version. No, they don't have this. Cool. It's a lot of math. I think we have it right. It's just like, so it's annoying because we have, this piece is technically parallel, but anything I've tried to like do this in parallel and sync it, it's just the same speed or slower. So this op here is eating 50 micros. The rest of it's eating 30 micros. Times faster. Yeah, but this is also the function that blows up if you do it wrong. So we can go to that, but I think we can get it faster before we get there. Memory layout change. Does that just work? I think it does. I don't think that that's totally helps though, because we still have this thing, it's still slow. Catch warp. It's a little bit obnoxious because it's like it's not element wise, right? Like this chunk here could be element wise, but then the rest of it is not. Like this stuff can't be done element wise. Inline actually do anything? Um, it makes me know that I'm not accidentally introducing overhead by the compiler doing something stupid. Probably the compiler is smart anyways, but I don't know. It was 80 micros before. Yeah, this is gonna write over. Oh, it's in backward though. And how would you go about doing that? Wasn't forward. Okay, so there's yeah. Cool. Which misses. Bathymetrics. Cache misses. Maybe not by default. I think that's a more NCU if you want that. Again, right? So FP16, BF16, these aren't using tensor cores. These are gate operations, so you don't even get a chance to take advantage of that hardware. And these are the most numerically sensitive operations in the network. So, not ideal. If anything, you'd want to stick the map moles in BF16. Honest. If it works. Yeah, but what happens if it works and then it fucking crashes your training run randomly, like on a bunch of experiments? I don't think, like, it's not going to be as big of a perf gain either. Like, this does not let us use tensor cores if we do it here. These are gate operations. Okay, that did not help at all. Yeah, that doesn't help at all. Cool, it's not load bound. Check this. Oh, this doesn't help. It's different. It's fairly different. Okay, so we are eating 30 micros. There's gotta be something for this, right? Oh, can this save us something? That identity? Well, because we're computing both, right? Hang on, what's this thing? Well, that's a gross thing that it ends up doing. What is this doing? Leave me alone. I think it did it kind of stupid. Yeah, see, it's barely better this way. The way that this gets put into gate, hang on. Coefs. Lots of improvements. We're at 8.8 million steps per second. Last stretch. Yeah, these are all like very small optimizations here at this point. Big chunky gate. You can, I don't know if you want to. See that guy? Yeah, we got several profiles. It's tough. Everything's pretty tight. Mm. Just very annoying, expensive gates, honestly. Yeah, see, this is such a mess. Well, I guess there are a few other things I wanted to check before I spend a huge amount of time on this. There's our 8, 8. Want to make sure this isn't slow. Okay. I think what we'll just do, just gonna comment this one. So we're gonna just understand that there's a little bit more overhead than there should be here. So we don't have to deal with this bullshit. Because this is just a quick test. If this gets more than a few 100K, like, okay, couple 100K maybe, not massive. Pretty variable, not massive. Flat profile as we expect. Super annoying to deal with flat profiles. We have a couple other things we can do. Let's go check on this fused loss. Yeah, again, like another 200-ish K. Very small. So we have micro optimizations we can make. The really annoying one is this one. Because somehow the frickin' Everything has so much overhead, man. I mean, like, the Muon steps should be allowed to take a little bit of time, but I think this goes over 10 just with this, right? Yeah, that gets you 10. Let's get our profile again. Eight 8.9. Okay. We're gonna get an end prof out of this. The thing is, there's still like all this massive element-wise crap that probably mostly comes from the optimizer, frankly. But I haven't looked at this in a while with fresh eyes. Yeah, that's not how it works. Okay, let's get our profile. And then I think I get myself a refill on my tea. And we consider what to do from here. So we have 38.9 actually spent in mat moles, which is better than before. This fuse scan is still obnoxious. And then a whole bunch of element-wise ops. It's a much nicer profile than before, at least. So these bad boys are from the optimizer being a pain. These kernels are actually pretty big now, aren't they? Advantage kernel is... Yeah, okay. A few other things. The thing is, it's like such a flat profile at this point. Does this give us something reasonable? Okay, not significant overhead from just clip. It is from Muon. How much do we get from just 0? How much do we get from this? A lot. Okay, so it is actually all right here. Wait, do we have both of these clips on? Let's make sure it's not this thing. Ooh. 0.9. It's not this. this right here, right? I'm gonna go use the restroom real quick, and then we will continue. We got 10% here. We got 10% in the kernels. We got like little bits of perf floating elsewhere. If we were at like 9.6, 9.7, I'd just start like cleaning stuff up and doing micros. But I think we're just a little bit too far off. Like we need one more actual optimization, and then we can just do micros. Anti-innovation. Yeah, no, the company's freaking mental hospital. I'll be back. Okay. So here's the story. We may as well do the fuse scan. It gets us a couple hundred SPS. We'll try this thing first. The heck is this? Huh? Does that even make sense? I'm highly doubting this, but we'll try this. Yeah, I'm not wasting mental bandwidth on this because I'm already on the next thing in my head. I think that this is actually, this op is implemented correctly, and it's just like genuinely some overhead. You pay 10% for Muon. Muon is worth 10%. It's fine. We don't worry about it. I think that's what it's going to be. Reducing the size. See, but if it's going to be a different approximation, yeah, I saw this. If it's a different approximation, the problem is this requires me to rerun all the experiments and stuff. Oh yeah, this one is not going to help either. Yeah, this one is not going to like super help either. It's more for bigger mats. So yeah, that's unlikely. Yeah, good job, Claude. That is way slower, as you would expect. Okay, whatever. We leave this alone. I'm going to do our fused. So we need, what is it? Yeah, so this has to get loaded in. It's something like this. We'll figure it out. I think we also have numerics on this. No problem, we'll see. Nine mil. Okay. We're unstable now, though, is the problem. We're unstable. Is it worth rerunning profile with this? I guess at least now we can rerun this little profile. Yeah. See? Okay. I just want to, basically, I want to see how many of these little small ops go away. That's all I want to see. There are like way too many little element-wise ops everywhere. It's just a flat profile, right? Okay, so this is fine that this is a double. Is it? I actually don't know. Because this gets coup de graph trace, doesn't it? Oh yeah, no, but this chunk doesn't, so we're good. Okay, we're generating report. It's ridiculous element-wise overhead. Fuse kernel. Put all these tiny little element-wise kernels, yeah? Oh, you know what, though? Hang on, let me think. We still want this, right? Triton code for Newton-Schulz. Yeah, so the thing I'm not sure is it selects some rows to do the iter on. Like it's already like I think 4 nanoseconds per matmol. There's just a lot of them. Honestly, I think the better thing is if we could figure out some way to batch it. Probably there's something that could be done with a batch matmol. Reduce kernel. Dot sum. Or mean. Here's the forward and backward kernel. And 1%. How long does it take to get lean muscular if you're skinny with high metabolism? I've been training about 5 years. It depends if you want to be healthy or you just want to be like, or you just want muscle. Because if you run as well, if you're actually getting good cardio, it takes much longer. It took me like, I think 3-ish years to hit 1, 2, 3, 4, starting at a body weight of 140 and then getting up to like 175. Um, but then it took me like another 2 years of running before I was able to do reasonable distances, and I think now it's been like probably 3 years ish of running, where I can pretty easily I can do training blocks for marathons within 6 weeks. Um, I've got a better 5K time than I had in high school, even though I'm 40 pounds heavier. So it takes time. You can do it. It's definitely worth it, though. It's like the one thing that actually is always worth it. 135, 5'9". Yeah, so that's basically where I started. Um, just go grab. Well, it's up to you if you care about like muscle versus strength versus cardio. I just go grab strong lifts. I mean, your super basic program is you do 5 sets of 5, bench, squat, deadlift. Split them up over the week, twice a week each. Deadlift only once. Add an overhead somewhere, probably with squats. Just getting some basic compounds in and actually eating, you'll put on like 20 pounds in a year. $42. I mean, I could have chosen 007. A short guy can bench 140. Yeah, that's way over my max. My best was 265 pounds, which is what, like 120-ish, maybe? Went on as 10. I didn't train that early, man. I only started doing weights when I was in my 20s. When I was a teenager, I was like not a great athlete, but I could play squash. I could run 2 miles, 14 minutes, and I could do probably around 15 pull-ups. That was about it. So, not great, but something. Name behind Puffer is the fish. The fish. Like this guy. Also, for folks watching, please star the Puffer on GitHub if you haven't already. We're almost at 5,000 stars. That would be awesome. That'd just be awesome. Survivors and Puffer survivors. Jeez. Alright, what do we do from here? We're kind of out of easy stuff to optimize. You can use them for some stuff. If you outsource your thinking to them, you're an idiot. And no, software engineering has been over for in 6 months for the last 3 years. People are dumb. You don't run RMS more. Yeah, we don't have RMS more. Stupid model. Use prioritization. Yeah, they're like a couple small sources. I actually do kind of wonder. Oops. How is this slower? Oh, it's not. It's fine. We're at 9. Cool. Uh, burned. No, what's that? I do not like Rust, my friend. Rust, no good. Of course, C++ is awful, so I'm not advocating this shit either. solve. I mean, the best thing I can do is like try to save some stuff off the kernels a little bit. Sometimes X eats messages, om nom nom. XT being symmetric. Yeah, it's the gram matrix, right, isn't it? If there's a kernel for this iteration that I don't know about, by all means, but I don't know anything. It's 10% in muon. There's 10% in this kernel somewhere, and then there's like another 10ish% floating around somewhere, just like with a bunch of little, much smaller things. We only need to calculate the upper triangle and copy it. Then you would think there would be a kernel for that, right? Funny enough, I don't see anything exploiting that. Probably because the hardware is just so optimized for matmols. Francisco's kind of dull. Let's see. Yeah, this is what I thought you could do. Let me make sure. I'm just trying, well, at the moment I'm cleaning this kernel up a little bit, but then I'm also trying to get some, squeeze a little bit of perf out of it. And then ideally, I think I should be able to do the same here. I don't really think there's too much coming from all this branching, though. I did measure it before, but there's not too much else we have that we can optimize at the moment, and these are a mess anyways. Oops. Let's see, so... Stupid fucking thing. We do move this out of loop. Yes, you can kill this branch, you can kill this branch. $75 micros. This kernel, this test has a few micros worth of play in it, so. It probably shouldn't, but it does. Okay, good. Log value. It's fine. That looks much better. Let's go double check this real quick. Has the opinion of it not changed at all since the not brain dead vibe coding? Yeah, it's pretty much if you outsource your thinking to it, you're an idiot. Um, it's useful especially for work that's very, very heavily redundant. Like, just the fact that CUDA kernel's bound to torch with all these additional things flying around. It's very verbose. You have to copy stuff in a bunch of places, guaranteed. It saves a lot of time because of that. It's good for some other things as well, but you definitely don't want to, like, if you're surprised by the code it's writing, you're doing it wrong. I think that you should generally, your goal should be that it writes exactly the code that you have in mind. Like, you want to train that loop so that, like, you will say, okay, this is the code that I want, this is how I think it's going to be implemented, and if it gets the exact code you would have written but faster, that's good. If it comes up with something surprising and diverges from your expectation, that's bad. Numerical stability, that's what this is for. We have more aggressive checks than this, but the current test is just does it train breakout. I think that this is a better check than just doing the single iteration ones, because I've had those fail, like those succeed before and this fail. So actual training is pretty good. T greater than or equal to 1. Yeah, so this is going to come out of this is going to be up top, right? Could just be trying to outsmart. I'm not, because I'm also cleaning it up at the same time. Like, this is disgusting to read. I think this is better, right? Let's double check. Oh, yeah. Oh, wait. Hang on. Oh, that's awful. No, that's fucking awful. What are you doing? I'll run it for the memes to see if it's faster. But that's awful. Symmetric rank K. If it's faster for these small maps, then by all means. Symmetric rank K. But it's not, is it symmetric rank K? That would be if we wanted low rank approx to low rank approx. Theoretically it should be 50, but it's gonna change the numerics, right? Because like we're not doing a low rank approx right now. Oh, I don't know why I did this. Hang on. I was supposed to build the profiler. Do we have numbers from before? 106. So I expect that this is not any faster and this is a mess. It's slower and a mess. Lovely. Yeah, we're undoing that shit. Faster gem for AAT. If it works for, I think our matrices are size 128 by 384, if you wanted to test it out. If it's faster, that sounds great. 50% speed up gets us, I don't know, probably 400,000 or 500,000 SPS. That'd be nice. Let me see what, let me actually just tell it what sections I can pull out. Let me see what the heck this is. Before and after. That's a mess. Man, grabs just get like unintuitively messy. See, the obnoxious thing about this, right, is it's like, hmm, it's all in here. Yeah, like this thing here. Okay, so we set. Let's see what this looks like. Yeah, this gets pulled out. The heck? The thing is, it's still gonna just all be in. We should just do a test to see if I comment this line, how much we save. So, because I think this is just cleanup and the rest of it will be perf. Like, it's gonna just be save a couple ops in here and then we'll be good. I'm just gonna let it do this and I'm gonna just check it. Okay, what do we have? We have, yeah, so this is what I would have had. See, it's like it's got more stuff outside of here. And this is fine. Now let's see if this is actually correct. If it's slower. Oh, it's way slower. Lovely. So if I just do this, well, that means that if that type of a thing can make it slower, %20 slower. If I could just shave 20% off of this. Okay, we'll try this and see if it restores. If not, we'll go back. Is your nvip config open source? There you go. There's hardly anything in it. So do we get something predictable out of this or not? Nope, not at all. Okay, very good. Let's go check this one. I've been meaning to do this, which is how much time is in here. $42. So 65-ish. 65-ish MS backwards. You call X of, so you want to cache this X if anything, right? Beta X. Let's see, we call this on negative hidden. Gate. Max 0, wait, 0 and X. This is hidden, right? We save a relu. Tiny. Yeah, it looks like the relo is not needed, right? Because it's already greater than 0. Relo is not like a big op though. I don't even think we'll see it in this. Yeah, it's in the noise. But now we still have to do build. Yeah, this is still fine. It's such a small optimization though. Like what we would really need. Oh wait, if x is greater than 0, hang on, we can get rid of this. If x is greater than 0, rad output, otherwise 0, right? Yeah, okay, that's something. I think this one works. I would assume that there is a way to do it, right? Because you can do it on the forward pass. Maybe you can do this. That seems sketchy. No, apparently this is a fine optimization. Let me try these fast sigmoids. Okay. Oh, wait, this was not remotely close, was it? It's unstable. No, okay, so let's do this. I don't know when the last time you looked is. BR. 124 mil. There's an eval thing at the end. Okay, so this is 105, so this is the same freaking speed. And what about with these fast sigmoids? Does it make a difference? That doesn't make a damn thing difference. Are we doing this right? It's like so weird that that doesn't make a difference. Yeah, look, the backwards 44. This is where it's coming from. I wonder if we have something done with this addressing. Hang on. But the thing is, the compiler might like optimize this out if I do this. And we'll see. Slower for small maths, not compute bound. Yeah, fun. Yeah, everything is tough with very small maths. '81, '82. Interesting. You know what? Here. Okay, this is what we're gonna try real quick. Ready? Yeah, I just want to make sure nothing weird is happening with this. Okay, so we get 74 and 105. Yeah, same exact thing. Cool. So we have sanity. A gram and X can use. Make sure it's not real. That could do something. Yeah, that I would believe could do something. Just make sure it's these sigmoids real quick. Let's just check my it's the two sigmoids, right? Let's just check my intuition. Interesting. You actually don't save that much. It's just a very flat profile, I suppose. How much if I do this? How much of the total time of the program is in sigmoids? Like nothing, really? Did I do this correctly? That's surprising. Yeah, nothing. Okay. This one then? I think this one's pretty heavy. No. It isn't. Hmm. It's very interesting how this works. Relo in the forward pass? Yes, I can. Thank you. Double check I didn't break anything. Nice. What happens if I do this? I'm just interested in this little branch right here. Yeah, you shave quite a bit, but then I don't understand how. Well, maybe it's this log. Is it like this? Oh, very odd how this works. This does not do anything, right? Like, this does not do anything. I'd be shocked. No, good. Solve plus negative hidden. Let me look. Is there a copy by creating a var before the if statement? I think we just tested removing one of them. I think the compiler gets it. Yeah, this is the same. This log1 pf xpep is annoying. Interesting. Hmm, hmm, hmm. Hmm. It's surprising to me that this is not faster. Like, it's very odd. Been about 5 hours. I've been optimizing a lot of stuff. A lot of stuff. Uh, Lots of very small little things. Yeah, I was thinking of it. And is this... That's fine. LM to do perf opt. Yeah, you can, and you can just ask Claude to try it. It's just not great. And like, it makes a mess, is the thing. Yeah, I know CUDA doesn't like if else if. Do you have a solution that doesn't involve computing them both anyways? Log coef and log z from one soft plus. Wait, you can calculate log coef. Isn't that what I just did? That is this right here, but you need two, don't you? There are three soft pluses in here. So you can save one of them. I don't think you can save two. Because you also have it on the hidden. We have this whole thing. Yeah, I got that one pretty recently, Rob. It was a very, like, small little bump. This one annoys me because, like, it seems like you should be able to just clean this whole thing up, but actually most of the overfed is in here anyways. Wait, let me see. Let's see what this guy sent me. Wait, float. We are using that identity. Wait. Did you not just write the same thing? Oh, you mean this conditional. Um, Hang on. That one I could believe. I could believe that the identity is applied wrong. Whoops. Did I just block you by mistake? I hope not. Something just came up. Okay, no, I did not block you by mistake. Type something to make sure. I want to make sure I didn't misclick you. Move the branching. Okay, let's see this. Float. Plus P8. Like this, yeah? Is that the same thing? About the same speed. Let me see if it does, if it breaks it. It's cleaner either way, so let me see if it breaks something. I don't see his name on the YouTube chat. Uh-oh, did I ban him? Let me go check my list. I might have misclicked him. Bot. Hang on. Let me make sure I didn't screw that up. I probably did. I might have to go to the web client. Alex. Where is my freaking ban list? I think I banned him by mistake. That's super annoying. Oh, there it is. I have a giant ban list from all the friggin' bots. Actually, I don't see him in here. I do not see him in here on the list. Unless it didn't sync. Just hang on. I don't see him on here at all. Unless my chat just like got screwed up. Oh wait, I might have put him on the YouTube block list by mistake. Stupid thing. It's like too easy to misclick that. Hang on, let me just go figure out what the heck. I probably misclicked blocked him on YouTube. Let me see where it is. New window. Oh, I don't even have that account signed in. That's super annoying. Let me fix that. No worries, I joined on X. I did ban you by mistake. My bad, dude. I will fix that. Yeah, I have to like go like get the client signed in and stuff. It's super annoying that like I can accidentally right click ban people by mistake. And there's no way for me to even open the view from here. Yeah, same person, different account, I figured. Here, let's see if your thing works. Because I gotta go for dinner soon. This does not train, my guy. I will double check it. I'm pretty sure it's different though. Yep, so the one that you gave me the first time is different, man. It's not numerically correct. You can try a couple quick things. If I do this. Oops. Probably side quest, yeah. Messages aren't going through again. That's not me. That's either X or restream filtering. It doesn't like links, it doesn't like things that it thinks are spam. If anybody has a better service than this, let me know. I will gladly switch. Let's see. I will grab your thing. Oops. I don't know. The freaking paste doesn't even work from here, man. Maybe it's the new lines. Alright, hang on. Let me go check. I got the same with my message above. Pretty sure that was the same one that didn't work. Yeah, 1 second here. Hang on, folks. Alright, I get ready in a second to go get dinner, but I gotta finish this last couple tests from you guys. Like this, right? Would be like this. No, this won't train. Yeah, this is not the same, right? Here, I'll test it real quick, but I don't think so. Yeah, no, that's wrong. Okay, let me try one last thing, guys. I just wanted to try messing the really easy thing. Now that we've done a bunch of stuff, I want to make sure that the kernel size is not like just a free bunch of perf sitting around here. I'm just gonna test this, and we're gonna go get dinner. Seven. Okay, so this is correct, but I don't think it's faster. But the thing is, I don't even think branching is the main thing. I think we're like splitting hairs over a couple micros that aren't going to actually make a difference. Let's see, log Z is gate minus SP gate. Okay, I think you're probably right that there is an optimization. You can paste it in the Discord, or I can do it after. Let me just double check one. Oops, what I just did this one, and where's the profiler? Yeah, so you don't get anything by increasing these kernel sizes either. I'll give you guys the quick rundown of this, and then I'm leaving for dinner. So what I've been doing here, this is a little bit of an annoying kernel because most of the compute is right here in the log coefficient values, which is element-wise parallel. You can do it outside the loop, but then you have this additional scan loop that's like not entirely trivial, but is substantially faster. So if you split this into two kernels, like the extra mem bandwidth overhead and stuff, you get just as slow. If you try to do a sync in between, like I haven't been able to get that to be as fast. So like the simplest thing that is also fast that I've seen so far is just to do this and then to try to optimize the operations as best we can. There's probably a fair bit you can do here. I have a lot of good profiling, but I don't have profiling down to the level of like, how much does this X cost us and stuff like that. So I think we can probably shave a good bit off of these kernels, and the fuse scan forward plus backward is like 15% of the program time right now. The other ones are pretty small, and the only sources of overhead, so we've got this, we've got like 10% for the Newton-Schulz iteration in muon, and then we have a whole bunch of unaccounted for element-wise op overhead, like another 15-20%, but I actually can't find it anywhere. Like, I think it's just a very, very flat profile over the rest of the code where you'd kind of have to go fuse things in one by one for 0.25% gains per thing that you fuse. So that's pretty much where we are with this. Regardless, though, right, we are at like close to 9 mil train, which is pretty awesome. If anybody wants to fix the fused loss kernel, it'll be 9 mil flat. 8.8 though. So I think that micros will get us up to like 9.3, 9.4 maybe. We got to find a couple other things to get our 10 mil. And then, once we get our 10 mil, we clean up and it's release time. Anyways, thank you all for joining me. I got to go get to dinner. I got dinner with family tonight. No stream tomorrow. Tomorrow I get some rest. You all can chat in discord.gg/puffer if you want. That's the main Discord. If you all want to help me out for absolutely free, please just star the repo on GitHub. We're almost to 5,000 stars. That will be awesome to hit that. You can follow me on X for more content. You can join Discord, of course.